I'm Anil Kumar. Welcome to my series on calculus. We'll discuss how do we find limits when we land in the situation where by substitution we get 0 over 0, right? So that is indeterminate form. So whenever it is 0 over 0, we are not very sure whether the limit exists or it does not exist. It may exist, right? One thing very important here is that it always indicates one thing, and that is to say that we have a common factor in numerator and in denominator, right? And that is the reason why we'll have 0 over 0. For example, in the first case, if I substitute 25 for x, we get 0 over 0. In the second case, if I substitute 0, we'll again get 0 over 0. That clearly indicates that x minus 25 is a common factor in the first case, and x is a common factor in the second case. Now, if that is known to you, then there are a lot of techniques which could be used. One of those techniques is factoring. Now, factoring can be used wherever, simple, because we have a common factor. So if you cancel out the common factor, then by substitution, we get our answer. Now, factoring could be complicated at times, and then in those cases, we prefer to use substitution. Right? Now, we could also use rationalization. To find the limits. So all the three techniques are well known and can be applied. Now if you look into these, then what I will do here is I will use factoring for these two examples. So if I factor numerator and denominator in these two examples, I'll be in a position to cancel the common factor, and then by substitution I'll get the limit. For rest of the questions, I'll prefer to practice substitution. We could do factoring for others also, right? Okay, so for factoring, there are two formulas which are extremely important, which I'll just mention here. One is you should know what is x cubed minus y cubed equals to, right? X cubed minus y cubed is x minus y times x plus xy. X squared plus xy plus y squared, right? And if we have x cubed plus y cubed, then it could be factored as x plus y times x squared minus xy plus y squared. Now these two formulas are very important to understand for factoring. Sum of cubes and difference of cubes, right? So you could use these formulas for many of these examples where I'm going to use substitution, correct? So let's begin one by one. So let me take question number A first. Now let's understand the method of substitution using this example. So we have to find limit when x approaches 25 and we have 5 minus square root of x over x minus 25. Clear? Clearly, if I substitute 25 here for x, right? So if I have 5 minus square root of 25 over 25 minus 25, it is 0 over 0, right? So it is indeterminate. And therefore, we need to use one of our techniques. So the technique which I am going to use now is substitution. So what I will substitute is, we'll look into this square root term, right? So what we'll do is, we'll sub square root of x as u. In that case, x becomes u squared. Now whenever you do substitution, you have to look into the limit part also. Limit says that x approaches 25, right? So if that is the case, then what will be u approaching, right? U approaches square root of x, right? U is square root of x, which is equal to square root of 25, or we can say u is approaching 5. Is that clear to you? Right? So these two are only here as a filler to make you understand why u approaches 5, since u is equals to square root of 25. You get the idea, right? So in later videos, I'll be writing it direct. Clear? Now once I have done this substitution, I can rewrite my limit as limit u approaches 5. And now we have substitute square root of x as u, so we get 5 minus u. And here, x is u square, so we'll write this as u square minus 25. Okay. Now, what you really see here is that we are still doing factoring. So we have u 5 minus u in the numerator. The denominator is difference of squares, right? So we know a square minus b square is equals to a minus b times a plus b. So that is difference of squares, which we are going to apply here. So it could be factored as u minus 5 times u plus 5. Now, clearly, this limit here can be written as limit u approaches 5. U minus 5, we could write this as minus of u minus 5 in the numerator, correct? And then we get u minus 5 times u plus 5. Now we can cancel u minus 5 and u minus 5. Once we do that, we can substitute the value of u, and what we get here is minus 1 over, when I substitute 5 here, 5 plus 5, so I get minus 1 over 10 as our answer. So therefore, this limit is equals to minus 1 over 10. Is that clear to you? Correct? So that is how we are going to solve this equation using substitution. I hope you have understood this part of substitution, where we substituted square root of x with u and the limit as x approaches 25 to u approaches 5. So that is very important to understand. Let's take up another example where this method of substitution is really very effective. So here, what we are going to do. So well, if I substitute 0, you can say I will get 2 over 2 minus. If I substitute 0 here, right, so I get 0 plus 8 to the power of 1 over 3 minus 2 over 0, which is 2 minus 2 over 0, which is the form 0 over 0. And therefore, we are using our technique of substitution, right? So now we are going to do the substitution. So we say let x plus 8 to the power of 1 over 3, that is cube root, be equal to u, right? So in that case, x plus 8 is equals to u cube, perfect. And x will be equal to u cube minus 8. So we know how u and x are related. Now, when x approaches 0, in that case, x plus 8 cube root approaches what? So we get 0 plus 8 cube root, correct? So this approaches 2. So that means u approaches 2. Clear? So that is the substitution which we are going to do. So we can rewrite the equation which is limit x approaches 0, x plus 8 cube root minus 2 over x as equal to limit u approaches 2. And here we have u minus 2. And instead of x, we are writing u cube minus 8, which is same as, you can see, limit u approaches 2, u minus 2 over u cube minus 2 cube, correct? Now again, we are going to use the factoring process, right? So substitution actually includes factoring, right? So we have here u minus 2 divided by u minus 2 times u square plus 2u plus 2 square, correct? Now u minus 2 and u minus 2 cancel, and we are left with limit u approaches 2 of 1 over u square plus 2u plus 4, right? So that gives us, substituting 2 here, we get 1 over 2 square plus 2 times 2 plus 4, which is 4 times 3 or 12, right? So we get this limit as 1 over 12. So our answer is 1 over 12. Is that clear to you? So that is how you should use the process of substitution. Now, you saw that in both the examples, we actually performed combination of substitution and factoring. That means that factoring is definitely a very useful method to do, right? Now, in this example, if I substitute 2 here, then we get 2 times 2 square minus 7 times 2 plus 6 over, we get 4 times 2 minus 2 cube, right? Now that is 8, and we get 8 minus 8 as 0. So 4 times 2 is 8, 8 plus 6 is 14, and 14 minus 14 is also 0. And therefore, we will apply to our technique. And in this case, as I was discussing, we will not apply substitution, but we'll directly go for factoring. Is that clear to you? Now, factoring was as such done in the first two examples also. So substitution followed by factoring is the normal technique. And here, let's do factoring directly, since the quadratic equation can easily be factored, correct? So we have this equation as 4x minus x cubed. Now the numerator, we want product of 12, sum of minus 7. So we could always write this as limit x approaches 2. So we have 2x squared minus, so 4 and 3, right? So minus 4x minus 3x plus 6 over. Here we could factor x out, right? So we get 4 minus x squared. So that will give us limit x approaches 2. You can take 2x common, and we get x minus 2. And here we could take 3 common, and we get x minus 2. And the denominator, we have x times 2 minus x times 2 plus x, correct? It is 4 minus x squared, right? Now in the numerator, we could take x minus 2 common. So we have x minus 2 common. We get 2x minus 3 as the other factor. In the denominator, we could write minus x, and this I could write at x minus 2, and that we could write as x plus 2, right? Now clearly x minus 2 can cancel, and we get limit x approaches 2 for 2x minus 3 over minus of x times x plus 2. Note that what was giving us 0 over 0 was this factor of x minus 2 and x minus 2. Since we have cancelled, now we can substitute and get our answer. So we get 2 times 2 minus 3 over minus 2 times 2 plus 2, right? So we get 4 minus 3 over minus 4 times 2 is 8, right? Or it is minus 1 over 8 as our answer. Is that clear to you? So you could always apply factoring directly without any substitution also. So in this case, it is important to note we directly apply factoring. Clear? Okay. So here is another example for you. Well, this is also a factoring example. If you substitute 4 here, you do get 0 over 0. I would like you to, at this stage, pause the video, solve this, and then look into my suggestions. The example here is to evaluate limit when x approaches 4 for 3x cubed minus 12x squared plus 5x minus 20 over x cubed minus 64. If you substitute 4 here, you will get 0 over 0. So that means there is a factor x minus 4 in both numerator and denominator. So the idea here is to factor and then solve. So we'll just factor this. So it is x to the power of 4. We can take 3x squared common in the numerator. So we are left with x minus 4. And we can take 5 common here. So we get x minus 4 divided by. Now this is cube, right? Basically, you can treat this as x cubed minus 4 cubed. We'll factor it later. So what we get here is limit when x approaches 4, x minus 4 is a common factor. We're left with 3x squared plus 5. And the denominator, we have x minus 4 times x squared plus ab, which is 4x, plus 4 squared, which is 16, correct? And now, clearly, x minus 4, the common factor in numerator and denominator, gets cancelled. And therefore, we could write this as limit x approaches 4, 3x squared plus 5 over x squared plus 4x plus 16. Substituting 4 here, we get 3 times 4 squared plus 5 over 4 squared plus 4 times 4 plus 16, correct? So which is 16 times 4 times 16 plus 5 over, so 16 times 3, right, which is 48. So we get 16 times 3 here also, right? 16 times 3, 48 plus 5 will be equals to 353 over 48, correct? So that becomes the limit for the given question, correct? So I hope that makes sense. Let's move on and take the next example, which is we need to now find the limit when x approaches 4 for 4 minus square root of 12 plus x and x minus 4. Again, if I substitute 4 here, we get 16 in the square root, which is 4, and 4 minus 4 is 0. So we get 0 over 0, right? So this also is a case of 0 over 0. Now here, you could do rationalization, right? So you could do rationalization to solve this. However, we will do substitution. So we say let square root of 12 plus x, let this be equal to u, right? In that case, 12 plus x is u squared, and x is equals to u squared minus 12. Correct? Now also, when x approaches 4, in that case, square root of 12 plus 4 will approach 4, right? 16 square root. That means u also approaches 4, correct? So we could rewrite now the question as limit, instead of x approaches 4, we'll write u approaches 4, and we have 4 minus u over, instead of x, we are writing u squared minus 12. Do you see that, right? So that gives you limit u approaches 4, and we have 4 minus u over, now this is 16, right? U squared minus 16. Now, sorry, this is product. So limit of u approaches 4, we have 4 minus u over, this could be written as 4 minus u times u 4, this is 4 square, right? So 4 plus u. Now clearly this 4 minus u cancel, and we get 4 plus u. One of them is a 4, okay? So what we get here is limit u approaches number 4, and in the numerator we are left with 1, and here we have 4 plus u, okay? Limit of this, which is definitely 1 over 4 plus 4, or 1 over 8, and that becomes our answer. Is that clear to you? So this is the way substitution can help you find limits, right? So here is another example, last two. Now again, if I substitute 27 for x, we do get 0 over 0. So what we will do here is that we'll sub cube root of x as u, right? That means x is equals to u cube. That is one thing. Second thing is that when x approaches 27, then cube root of 27, right? Cube root of 27 approaches 3, correct? So basically, it is equal to 3. So u approaches 3. So we could rewrite this as limit u approaches 3, and x is substituted as u cube. So we get u cube minus 27 over u minus 3. So radicals have been changed to cubic functions. That makes it simpler. That's the whole idea, right? So substitution helps you make the problem simpler. The steps are more or less same. So you got u minus 3 times u square plus 3u plus 3 square, which is 9. So I directly written here. And we have u minus 3 here. This u minus 3 cancels, so we get limit u approaches 3 for u square plus 3u plus 9, right? Substituting 3 here, we get 27. Sorry. Okay, so let me write 3 cube plus 3 times 3 plus 9. Oh, sorry, 3 square, sorry. 3 square, okay. So divide by 1, right? So what we get here as 9 plus 9 plus 9, which is 27, clear? So we get this answer as 27, right? Is that clear to you, right? So that is how we are going to answer this particular question. So let's move on and take the next question now. It is very similar to what we did just now. We need to find the limit when x approaches 0 for x over 2 plus 3x minus 8 cube root, right? So let's do the substitution. So substitution will be 3x minus 8, let it be equal to u, right? So if that is the case, in that case, what is going to be x, right? We need to know what x is. So rather, this is cube root of this is u. So we have 3x minus 8 equals to u cube. So 3x is equal to u cube plus 8, and x will be equal to 1/3 of u cube plus 8. Clear? Now secondly, we need to check the limit, right? So when x approaches 0, the value of 3x minus 8 to the power of 1 over 3 is equal to what? It is minus 8 to the power of 1 over 3, which is minus 2, right? So that means u approaches minus 2. Is that clear to you? So in this case, we have this kind of substitution. So let's make this substitution and then solve. So we get limit u approaches minus 2, and x value is 1/3 of u cube plus 8. In the denominator, we have 2, and the whole thing here is u. Clear? Now 1/3 is independent, so we can bring 1/3 outside. So we get limit u approaches minus 2. We can expand this as u plus 8 times u square minus 8 means 2 cube, right? So that means 2u plus 4, which is 2 square divided by 2 plus u. 2 plus u, right? This is, sorry, 2, let me rewrite this. So basically what we have here is limit u approaches minus 2, and we have 1 over 3 times. This is u cube plus 2 cube, right? So we have u plus 2 times u square minus 2u plus 2 square, which is 4, divided by 2 plus u, correct? So 2 plus u and u plus 2 cancel. So we're left with limit u approaches minus 2 of 1/3 of u square, minus 2u plus 4, right? So when you substitute this, you get 1/3 of, so minus 2 square, which is 4, minus 2 times minus 2 plus 4, correct? So this is equal to 1/3 of 4 plus 4, this is plus, right? Plus 4, 12. So 1/3 of 12, which is equal to 4, correct? So this limit answer is equal to 4. Is that clear to you, right? So that is how we are going to answer this question. So I hope the steps are clear, right? Now let's take the last example here, which is limit x approaches 1, x to the power of 1 over 6 minus 1 over x minus 1. So here we'll substitute x to the power of 1 over 6 as u. That means x is u to the power of 6. Now clearly when x approaches 1, x to the power of 1 over 6 will be equal to 1, and therefore u also approaches 1. Correct? Making this substitution, I could write this as limit x approaches 1 for, let me copy the question now. We have x to the power of 1 over 6 minus 1 over x minus 1. So I'll rewrite this as limit u approaches 1, and x to the power of 6 is u, so we get u minus 1. X is u to the power of 6 minus 1. Clear? Now see, this could be written as square and cube. Is that clear to you? So we'll write this as limit u approaches 1. So we'll do factoring now. So it is, think like this. It is u square cube minus 1 cube. Think like this, okay? Then it is easy, right? So what we get here is u minus 1 in the top, and that square thingy gives you a minus p, which is u square minus 1 times a square, so u to the power of 4, product of these two, which is u square, and 1 square is 1. Is that clear to you? So that can be written as limit u approaches 1, and we have u minus 1 in the numerator. The denominator u square minus 1 can be furthest factored as u plus 1 times u minus 1, and we have u to the power of 4 plus u square plus 1. Correct? Now these two factors cancel, so we get limit u approaches 1, and we have all this 1 over u plus 1 times u to the power of 4 plus u square plus 1. Correct? Substituting 1 here, what do we get? We get 1 over 1 plus 1 times, we have 1 plus 1 plus 1. That means 3 times 2 as 6. So our answer here is 1 over 6. Clear? So this limit is basically 1 over 6. So I hope that helps to understand all these steps. And that is how we are going to answer this particular question. Now, feel free to write your comment, share your views. And if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.